So in number 15, the remainder theorem states that when a polynomial f of x is divided by x minus 2, the remainder can be found by evaluating f of 2. Because if you recall, we take that factor, x minus 2, we set it equal to 0, and that gives us x equals 2, and that is what we would use to substitute into the polynomial f of x in order to find the remainder. Okay, that's the remainder theorem. According to the factor theorem, if a divisor gives a remainder of 0, then that factor divides evenly into the polynomial. So if f of negative 5 equals 0, that tells me that the factor x plus 5 divided evenly into f of x with no remainder. Okay, then in number 17, we want to use that remainder theorem to determine if x plus 3 is a factor of 3x cubed plus 2x squared minus 19x plus 6. So I would be evaluating f of negative 3 by substituting a negative 3 in for all of the x's in my polynomial. So 3 times negative 3 cubed plus 2 times negative 3 squared minus 19 times negative 3, and then plus the constant of 6. And that, when we put that in the calculator to evaluate, gives us a 0, and that 0 is the remainder. So since we have a remainder of 0, x plus 3 is a factor. Okay, then when we do that with number 18, we want to see if x minus 3 is a factor of 3x cubed plus 2x squared minus 19x plus 6. So we're going to evaluate f of 3 by substituting 3 in to our polynomial for each of these x variables. And when we put that in the calculator, we end up with 48. Okay, that 48 is the remainder. Since the remainder is not 0, we know that this x minus 3 is not a factor of the polynomial. Okay, so then in number 19, we're asked to divide the polynomials and write the quotient in standard form. And since this divisor is quadratic, I need to use polynomial long division. So I'm going to divide x squared plus 3x plus 1 into 3x cubed plus 4x squared minus 12x plus 3. So I ask myself, what do I multiply times x squared to get 3x cubed? And that would be a 3x. Then we multiply. 3x times x squared is 3x cubed. 3x times 3x is a positive 9x squared. And 3x times 1 is a positive 3x. Then we draw a line and change the sign, and remember we have to distribute that negative, so we're subtracting each term when we combine like terms. So 3x cubed minus 3x cubed is 0. 4x squared minus 9x squared is a negative 5x squared. And then negative 12x minus 3x is a negative 15x. And then we bring down the next term, which is the constant 3, and repeat that algorithm. So what do we multiply times x squared to get negative 5x squared would be a negative 5. Then we multiply. Negative 5 times x squared is negative 5x squared. Negative 5 times 3x is a negative 15x. And negative 5 times 1 is negative 5. And we draw a line, change our sign, and remember to distribute that negative when we combine like terms. So negative 5x squared minus a negative 5x squared, that's a plus then, and those cancel. Negative 15x minus negative 15x, minus and a minus is a plus, and those cancel. 3 minus negative 5 is going to be minus a negative, makes that a positive 5, and 3 plus 5 is 8. That 8 is the remainder from that long division, and so I'm writing my quotient then as the quotient 3x minus 5 plus the ratio of the remainder 8 over the divisor x squared plus 3x plus 1. And that would be the solution in standard form. Okay, then in number 20, I have a linear divisor, so I can use synthetic division. And I have a x minus 6, so I'm going to divide using 6 out front. And then I list my coefficients in decreasing order of exponent, putting in zeros for missing place values. So I have 3x cubes, negative 16x squareds. I put in a 0 as a placeholder for the x term, and then a negative 72 for the constant. And we're going to bring down the first value and then multiply. 3 times 6 is 18. Add negative 16 plus 18 is a positive 2. Multiply. 2 times 6 is 12. Add 0 plus 12 is 12. Multiply. 12 times 6 is 72. Add negative 72 plus 72 is 0. That 0 is the remainder, and that's preceded by the constant, the x, and the x squared. So the quotient in standard form is 3x squared plus 2x plus 12, and there is no remainder.